this on the computer. So those who just came to the class here, log in. Please make sure you guys try to do this quiz. You have to use a unit circle that you learned on last week Wednesday, which is this unit circle. Okay, I hope you still have this with you. To figure out this value, the function value. So you have to figure out what is cosecant 150 degrees, tangent 3 pi over 2, so on, so on, so on. The unit circle will be a good practice. And something that you guys need to do. So please, if you want this quiz, you're going to print it out and do it on your own. I will put it in the chat room so you guys can, practice this. This is pretty much important here. It's in your test, that's why. So I'm going to send this out to your chat here for a minute. Let me just find where is this located at. Number 4. So if you guys want to print it out on this quiz number 4, actually quiz 5 that I posted there, it's just a so it's in the chat place. So if you guys want to print it out, it's up to you. If I have a printer next to you, download it and then save it to your computer. Otherwise, I would recommend you, if you can see it from here, try to do this quiz. I'll give you guys like 10-15 minutes to do it. You do not, if you didn't finish it, I recommend you to go home and finish up yourself here. So use your unit circle trigonometry that I teach you last week how to figure out. And I think on Monday I show you a video how you learn to draw the unit circle quite fast, because the third test you can use a unit circle. You need to draw it out, but the last test you have to draw it out actually. I think there is a teacher teach you really quick way. Things like 15-20 minutes long. So please watch those. Yep, I will call you guys to do this. This is actually in your 6.3 homework. This is your 6.3 homework. Does anyone know what to do here? I'm just worried. Some of you like quiet here. Anyone know what to do? Don't use your calculator. Please do not use your calculator. That will defeat your purpose of. Calvin? Yep.
Is it 5 pi over 6?
Oh no. So if you give me this as 5 pi over 6, this is wrong. I am not going to call you to convert degree to radian here. So this is what a mistake students do, is they convert this 150 degrees to radian and then radian. This question did not want you to convert degree to radian or radian to degree. This question wants you to figure out what is cosecant 150 degrees. Example, cosine pi over 6. If you look at your unit circle, pi over 6 is this one. Cosine pi over 6 is the x value. So your answer will be square root of 3 over 2. So cosine pi over 6 is root 3 over 2. So that is the meaning of this. Not converting degree to radian or radian to degrees. Anyone want to try the first one? This is in your third test. I'll leave the last two for you guys. So anyone know what to do with cosecant 150 degrees? So you have to use your the unit trig circle here. And if I ask for cosecant, cosecant is 1 over y. So can someone tell me, using this circle, where is 150 degrees at?
Second quadrant.
This one, right? The blue one, right? And in order for you to find the cosecant is 1 over y. So this is 1 over y. Can someone tell me what is y value for the 150 degree is?
1/2.
1/2. And what is 1 over 1/2? 2. So cosecant 150 degrees is 2. You guys got it now?
Yeah.
I want you guys to, yep. This is very important class. I really want you guys to know how to do this. This is so important that a lot of students, this is 10 questions in your test, 1 point each. And if you cannot do this, you get, and if you give me like, 150 degree is 5 pi over 6, you get 0. This is so important. Anyone wants to try tangent 3 pi over 2? Andrew?
Is
And
it -1 over 0?
yep. So it's gonna be tangent is always y over x. So y in this case is what? -1 over 0. And what does this means? Anyone know what -1 over 0 means?
Undefined.
Yep, this is the answer I'm looking for, is undefined. That is what I'm looking for. Don't give me -1, 0 in your test, you will get full points. Go ahead. I want you guys to find what is sine 360, cotangent 4 pi over 3, secant, these things. Very important. Henry, you got sine 360 degrees? Henry? I'll let you do it. Henry says 1. Can someone tell me sine is the x value or the y value? Now he's changed it to 0 now. So sine is what value? X or y? Sine is the y value. And what is your y value in this case? If it's 360, this is a 360. And the coordinates is 1, 0. So what is the y value in this case?
0.
So in this case, sine 360 will be 0, not 1. Cosine 360 degrees will be 1. Right, next, cotangent 4 pi over 3. Avery, you want to try this? Cotangent 4 pi over 3. Cotangent 4 pi over 3. Avery, try it. Anyone?
Negative,
Andrew? Yep.
negative
Calvin?
1. Negative 1/2 over negative square root 3. 2
Yep.
over.
So cotangent 4 pi over 3 is this one. So the coordinates is this. And cotangent is what? X over y or y over x?
X over y.
X over y. So that's why your x in this case is negative 1/2. And your y in this case is negative 3 over 2. Okay, I'm going to put it down here so I got more room.
I have a question.
Mm-hmm.
Do we have to rationalize the
Oh, yes.
denominator?
Oh, yes.
So in the homework, we didn't have to.
In the test, you do.
Okay.
So the 2 will cancel out here. The negative will cancel out here. What you left is just 1 over root 3. And yes, you have to rationalize in your test. So what is the rationalize of this case?
3 square root 3 over 3.
Yep. So this is your answer here. Mm-hmm. You have this one, right? So, yep. Continue, secant 2tan. Andrew, Nukin, Ni. Number 5, secant 2tan degrees. Nukin. 2tan, secant 2tan. Yep. I didn't get you, Nukin.
Hello.
I can hear you now.
Okay. It says it 1 over the negative square root of
X or Y?
is x, so it's 1 over x, right?
Yep. Secant is 1 over X, cosecant is 1 over Y. And what is X in this in 2tan? Nukin.
The negative square root of 3 over 2.
So does anyone know how to do simplify this?
The square root of 3 over negative 6.
Nope. Good try. So what we do when you have 1 over means you take this and you flip it, right? So what is 1 over negative root 3 over 2? This is 2 over root 3. So you flip this fellow. And does anyone know how to rationalize this negative 2 root 3 over 2?
Is it 2 square root 3, negative 2 square root 3, and then 3 at the bottom?
Yep. So negative. Yep, that is correct. You guys okay here now? Because it's asked in your test, worth a point each. Cosine pi, Andrew. This is easy. Andrew?
Oh, -1. My mic was muted.
Yep, you're fine. So cosine pi, cosine means it's x, and pi is right here, it's -1. Yep. Ni, can you do cotangent 120 degrees? Ni? Ni, are you there? She replied. 1 over by cotangent is let me see, cotangent is x over y, right? And she say 120 degrees is right here. This is the green one. X is -1/2. Very good. So this is x -1/2. And your y in this case is √3/2. Yes. Now we need to rationalize, we need to simplify this. This is correct. We just need to simplify this. Anyone know how to simplify this icky fraction, quite complex fraction? What happens to your 2?
Get rid of them.
Get rid of it. So we still have a -1 over √3. Anyone know how to rationalize this?
-1 square root 3 over 3.
So it's -√3/3. The one you can throw it away, or you can put it down there if it's fine with you. You guys all right? Number 8, Avery, can you do what is sine 5 pi over 6 is?
Would it be 1/2 over square root of 3/2?
Don't forget, sine is what? X, y, or xy, yx, x over y. What is sine?
Oh, it's y over x.
I'm sorry?
Oh, y over x.
No.
Y over R.
In this case, sine in this
Just y.
case is just y. And because your radius is 1, so just y. And what is the y value in this case for 5 pi over 6?
1/2.
This is just 1/2. Yep. So make sure you guys know that this is very important. Sine theta is y value, cosine is x value, tangent theta is y over x, and then the rest. So it's not always x over y, it's only sine, tangent, cotangent is the one that y, x, and xy. Okay. I still haven't done 9 and 10, but I really want you guys to do it on your own. The last two, please do it on your own now. Number 9. Cosecant 300 degrees. And the last one, number 10, secant 3 pi over 4. Please do this on your own. And make sure you have a unit circle here to help you. Anyone how to do cosecant 300 degrees? Anyone?
Is it negative square root 3 over 2?
So cosecant is 1 over what?
Y.
Y. And what is y in this case?
Negative square root 3 over 2.
So it's the green one, which is 300 degrees, is -√3 over 2. Anyone know how to rationalize or
-2 over the square root of 3/3.
Yep. So it's -√2 -2 root 3 over 3. Yep, which is very similar to secant 210 that we just did, number 5. And the last one is secant 3 pi over 4. I don't have room here. I'm going to write it here because there's more on this side. So what is secant 3 pi over 4 is? Anyone? Secant is x, y, 1 over x, 1 over y, x over y, y over x. Which one?
Over X.
1 over x, yep. And what is 3 pi over 4 for the x value?
-2 square. I meant negative square root 2 over 2.
So it's x, so it's a negative. So this is 1 over negative root 2 over 2, because it's this one, the yellow one. Anyone know how to simplify this 1 over of that? So the 1 over means we flip, right? So it become -2 over root 2. And we have to rationalize this. So we multiply this by root 2. So it's going to be -2 root 2 over 2. This 2 will cancel out. So what is your answer here?
Negative square root 2.
Yep, negative square root 2. So this is the reduce. So make sure you guys, I do need to reduce this. Don't leave me this answer. 1 over -2 over 2, you will get 4 points. Questions, how we do use this to do him? Anyone have any questions? Okay. Now, what we doing here is I give you the angles. They can be in degrees, they can be in radian, and I want you to figure out what is the function value of it. So sometimes we do the opposite. Opposite means that I give you the value, like number 11, 12, and 13, and you have to give it to me the angles. So opposite. So example is, we know that based on what we did here, secant 150 degrees is 2, right? So if I ask you cosecant theta equals to 2, then what is this theta is? Your answer will be 150 degrees. Okay, so that means for this kind of question, number 11, 12, and 13, they provide you the value, they provide what we need, but we have to figure out what is the angle for this. So for question 11, we kind of did question 11, but make sure you know that this goes to 0 to 90 degrees. Class, is 150 degrees in this range, 0 to 90?
No.
No, so you cannot do 11 for 150. But if you look at the unit circle, 150 degrees is a blue one, right? Can you tell me what is the reference angle for that in the 0 to 90 degrees?
30.
And in radian will be pi over 6. Yep. So in this case, for question number 11, your theta will be 30 degrees or pi over 6. So that is how we do question number 11. So this is what we call as inverse trigonometric function. That means you do the other way. Okay. So can someone tell me for question 12, what is theta will be? Because they want it in radian. So sine theta equals to root 2 over 2. So what you need to do for this case class is I want the angles. So look at quadrant 2 and they ask you for sine. So can someone tell me which of this sine value give us root 2 over 2? What is the angle value here?
45.
So because sine is an x, a y, sorry, sine is a y. So in this case, your answer will be 45 degrees or pi over 4. So I just want to point out to you guys that if a question gives you this, how you read it from your unit circle is your answer will be one of these coordinates, right? You take 1 over x, or 1 over y, or xy, or something else like that. But if the question is asking you to find theta, then your answer will be either the angles, will be 330 or 11 pi over 6 or something else. But for this question, they only want us to do from what happens to my for this question, they only want us to be quadrant 1. So that's the reason why that we stick with quadrant 1. So can someone tell me how we do question number 13? Secant theta equals to √2. Anyone? Secant theta equals to √2. What is theta in this case? Now, because we are not familiar with secant, so we can change it to the reciprocal. Does anyone know what is reciprocal of secant? Sine, cosine, or tangent?
Cosine.
So cosine theta, and what you do is you just flip this because you reciprocal it. So this is 1 over √2. Can someone rationalize 1 over √2?
√2 over 2.
2 over 2. So now this is the same thing. So what is theta in this case for cosine theta is √2 over 2.
45.
Again, is 45 and pi over 4. You guys all right here? So this is how we do 6.2 because your angle is acute, means it is between what, 0 to 90 degrees. Okay. And I'm going to show you what happens in 6.3 homework, because in 6.3 homework, your angle changed a little bit because now your angle is no longer from 0 to 90. Your angle in this case is from 0 to 360. Okay, so this is the same thing, like what we did 6.2, but now it's 6.3. The angle is no longer in one quadrant, it's in all 4 quadrants. So how do we do this for question number 14? Cosecant theta is 2√3 over 3. So cosecant theta is 2√3 over 3. And this is number 14. So this time, this is 1 full revolution. So anyone know how to do this one? Yes, you can just use sine, cosine, tangent, but if I give you cosecant or secant and cotangent, you have to change to sine, cosine, tangent. Yep, so like this case, if you look at the unit circle only give you x, y, and so it's only this. So unfortunately, you have to convert this. Anyone know what is the reciprocal of cosecant?
Sine.
So sine theta. So you have to flip this, which become 3 over 2√3. So because you change, and can someone help me to rationalize this?
3 squared 3 over 6.
Yep. Because 2 times 3 is 6. Can we reduce this?
Yeah.
This is √3 over 2. So can someone looking at here, now you're going to look for the whole circle. Which one is given us √3 over 2 for sine? Sine means it has to be what value for sine? X or Y?
Y.
So which?
I think it's 120 degrees.
So it's
2 pi over 3.
That's 120, 2 pi over 3. What else also? What else? Can you tell me?
60 degrees maybe. Pi
Yep,
over
so don't
3.
forget, yep, sine is positive in quadrant 1 and quadrant 2. So if you are looking for the green one, so your answer in this case is 60 or 120 or pi 3 or 2 pi over 3. Because if you look at the question does want you in terms of degrees. and in terms of radians. So in this case, your answer will be 60 degrees, 120 degrees, or pi over 3, or 2 pi over 3. Okay, so that is how we use this two, the one in green. You guys all right? And the last one we're gonna do is number 15, is tangent theta. And the question is given us tangent theta in this case is equals to 1. Okay, I just copy down here. So can someone tell me what is theta? Again, use your unit circle. That's the reason why I recommend you to get used to your unit circle here, because you will be using it quite a lot. Oh my God. Okay. All right. Someone know what is tangent? So 1 is 1. So what, anyone know what is tangent theta? Give us 1. What angle give us 1 for tangent theta? So for the tangent theta, you look at the y over x, the one underneath the coordinates, that is tangent. So it will be, yep, 45 degrees or 225, because our tangent is positive in quadrant 1 and quadrant 3. And the radian is pi over 4 and 5 pi over 4. So that is correct, Ni. So theta in this case is 45 degrees or 225 degrees. In radian will be pi over 4, 5 pi over 4. Questions? Anyone? Anyone have any questions with this type of questions? Because it's very important. Let's look at some examples more. So when they ask you to figure out like number 16, given us that the t is 5 pi over 6, you have to figure out what is sine t, cosine t, and tangent. Find a point. Now the xy, if you look at 5 pi over 6, is very easy to do. Question 16 is if you have a unit circle. So where is 5 pi over 6? 5 pi over 6 is this one, right? What is the coordinates of that? It will be what?
Negative 3 square root, negative square root 3 over 2 and 1/2.
So that means that these coordinates will be square root of, as what Calvin says, negative square root of 3 over 2 and 1/2. So that is your coordinate point xy. So can someone tell me what is sine t in this case? Since we got this coordinates point, can someone tell me sine is for what value? X, y, or x over y? Y over x.
Y.
So what is y value in these coordinates?
1/2.
1/2. Cosine t is going to be the x value. Yep. Which will be what?
Negative square root
Negative square root of 3 over 2. And tangent t, you divide, right? You divide the coordinates, which is y over x. So you take the 1/2 divided by the negative square root over 3 over 2. And you guys know what happens when the 2 and 2 got canceled. So what you have is negative 1 over square root of 3. And you need to rationalize this, don't forget. I know your homework does not need to, but I will tell you in the test, I do want you to rationalize. So for tangent t in this case will be negative square root of 3 over 3. You guys doing all right here with this kind of questions? Okay. For calculators, you just it's a question asked, you just calculate, use your calculators. The only thing you need to watch out here is make sure that your mode is set to degree. If you see degree, And if you don't see degree, make sure your mode set in radian. Okay, so every calculator has a different mode change. So like here, if you see DEG is a degree. So for this, it's easy. I just tap on there and it will change to degree radian. We don't use GRAD, which is gradient. We don't use that. So only degree radian. So make sure you know which one to use. If you have the TI, the scientific calculators, you need to look for the mode symbol and make sure you know how to change the mode from degree to radian and radian to degree. And sometimes they use the D words. So if you see in your display, a D means it's a degree, a R means it's a radian. So a lot of students get wrong in your homework here is because they did not change your calculator mode here. You guys all right here? Anyone have any questions for me with 6.2 and 6.3? Because we have some, I'll do a little bit of 6.2 because there are some formulas in 6.2 here. In 6.2, there are some horrible formulas. Some of you will look at it. So this page, you see all this formula here. These are the formulas that you need to remember in chapter 7. So when we finish chapter 6, chapter 7 will be used in this case. Some of the formulas you already know, like the reciprocal identities, which is sine is 1 over cosecant, cosine is 1 over secant, tangent is 1 over cotangent. I think that one you guys are familiar with. Okay. Now that is also another identities called the quotient identities. This quotient identities is changing tangent or cotangent in terms of sine and cosine. So I'm going to put it down here. This is very important. Is to change tan or cotan to become sine and cosine. And means both. So so this is the useful of quotient identity. So you can change tangent to become sine over cosine, or cotangent is cosine over sine, which is a flip of that. So this is very, very important. And the last one is the Pythagorean one. So out of all this is the super, super, super important. This Pythagorean identity can only be used if you square your trig. Okay. So if you see any squaring like sine square, cosine square, tangent square, you will be able to use this Pythagorean identity. Sine square theta plus cosine square theta equals to 1. This is the most basic one. And so what I want to point out here is that you can derive the other one from here. Okay, so you can derive it from here. So this is 6.3. For example, is when I want you to derive is we have sine square plus cosine square equals to 1. So if I want it to become this, the tangent square, and we know tangent is sine over cosine. So what do I do here is I will divide both sides here by cosine square. So sine over cosine, you will get tangent square. Cosine over cosine is 1. And 1 over cosine is 1 over cosine is secant square. So it's 1 over cosine is secant square. So you get this formula, 1 plus tangent square equals to secant square. So this is what happens when you divide this by cosine square. And if you want to get the third one, which is this one, 1 plus cotangent square over cosecant square, can someone kind of tell me what do you do here? Anyone? You take this below, anyone? So here you divide this by cosine square. What do you think about this one?
By cosine.
No, divide by sine square.
Sine.
That's fine, you're fine. You're close. which is good. So when you divide this, you get 1. Cos over sine is cotangent square. And 1 over sine is cosecant square. So you find out that you will get the third formula here. Okay, which is this below. So usually I told students to just memorize the first one, which is easy, sine squared plus cosine squared equals 1. And then the other two can be derived by dividing both sides, everything by cosine squared, you will get the second one. Or you divide everything here by sine squared, then you get the third one. So so this is, I don't usually want students to memorize so many formulas. So this formula is the one that I would want you to do. And what is sine squared theta? Sine squared theta is you take the sine theta, the whole thing, and you square it. For example, is remember we do sine 30 degrees, right? So if you look at a unit circle for sine 30 degrees, anyone know what is sine 30 degrees for the unit circle? For sine 30 degrees. Sine 30 degrees. Anyone? Anyone? It's 1/2. Okay, sine 30 degrees is the y value 1/2. So what happens when you do sine squared 30 degrees? Sine squared 30 degrees means you take this 1/2 and you square it. So it's 1/4. Okay, so this is a meaning when you see the square here is you find the sine 30 degrees or sine theta first and you square it. So that's why in your notes here it's written down as that. So you take the sine theta or sine 30, sine 45, sine 6, do it first and then you square it. It's not the same as sine theta square. So make sure that your 2 is in the middle here. What is this sine theta square means you take the square of the theta first and then you do the sine. So for example is if I want to do sine 30 degrees square, this is the same as sine 900 because you are squaring the 30 degrees. So 30 times 30 is 900 and sine 900 is some numbers. I'm going to cheat a little bit because you can use the, I will show it to you how to do this. I should show it. No, I should show it to you how to do it. Anyone know how to find sine 900 degrees? This is also important. Yes, we use a unit circles, but before we use, now the unit circle is only good for one revolution. Okay, half, maybe, I do not know, let's check. Yeah, you calculate, try not to use. So what do I do here is we want to make it back to the unit circle. So I will do what we call as the what was that called? The one that you learned 6-1. Let me see, 6-1. We have coterminal angles. Yes, coterminal angles. So what do I do with this 900 is I will minus this 360 because it's one revolution until the angle reach in between 0 to 360. So if I take 900 subtract 360, I don't think so. That one is big. Not in, so 900 take away 360, still
180.
bigger. So 180, yeah. So this is actually is sine 180 degrees. And then now you can use a unit circle because it's, what is sine 180 degrees, anyone?
0.
The answer is 0. So in this case, sine 900 is answer is 0. So your answer is not the same. So sine squared 30 degrees is a quarter. Sine 30 degrees squared is 0. So again, there's a reason why that these two are not the same. They are not the same. Okay. So that's why I want to point out to you guys. So how do we apply this kind of oh, that's another one I forgot. It's the complementary angles. What is the core functions of complementary angle? It means that if you add these two angles up, it is complementary. Complementary means 90 degrees. Sine and cosine is complement core functions of complementary angles. Tangent, cotangent is also complementary. Secant, cosecant. What does that mean here is if you want to use this this kind of complementary angles. So if I want you to find cosine 32 degrees, Cosine 32 degrees is the same thing as sine 58 degrees. The reason why is because if you add these two angles up, you should become 90 degrees. That's called a complementary. Okay, 32 plus 58 is 90, right? So this is the meaning of it. So sine and cosine is co-function to each other. And if I want you to find tangent 20 degrees, so tangent 20 degrees is the cotangent of what degrees?
70.
70. Because again, when you add this, you get 90. Same thing with secant and cosecant. So secant of 35 degree is the same thing as cosecant of what?
65.
Okay, 65. Again, you just add. Now it can be radian. So if it's radian, then we don't use 90. It will be what? Pi over 2. So if I give you sine pi over 8, then this will become what? Cosine of what? So what you do is you take pi over 2 minus pi over 8. If you have your calculator, you just do 1/2 minus 1/8. Anyone got an answer here?
Over 5.
3 pi over 8. This is 3 over 8. Okay. So cosine pi over 8 is cosine 3 pi over 8. Again, when you add these two up, it's 90 degrees or pi over 2 in this case. Okay. So this is how we do the co-functions of the complementary angles. And yes, this whole page, you need to know that. This is very important. Okay. And then there is also another thing. So this whole page is important. And there is also another thing that is important is in 6.3, we call that as your even odd functions, even odds. So this is an even odd trigonometric functions. This is used for negative angles. So this is used for negative angles. And you want to change them to become positive angles. Okay. So cosine and secant are what we call as an even functions. What is even function? It means that when you put the negative angle, cosine of negative t means the angle is negative. That negative disappeared. You got cosine of it. Okay, same thing with secant. For the sine, tangent, cosecant, and cotangent is called the odd functions. What's the meaning of odd function is when you have sine negative t, the negative actually move to the front, become negative sine t. Same thing with cosecant, cotangent, and tangent. Now, this is very important, especially when we do negative angles. As you know that when you look at your unit circle, this unit circle is all measured in positive angles, right? So what happens if I want you to use find a negative angles? One way you can do clockwise, you can do that. Or another way is you use the even odd functions. For example, what is sine of negative 3 pi over, let's say, 4? Okay. So what we do here in this kind of, when you have a negative angles, so you will use what we call as the even odd functions here. And sine is an odd function, so the negative, you will have to bring it up. So what happens when I want you to find this sine of negative 3 over 4? This negative will bring up, so this is negative sine 3 pi over 4. So what happens is your angle is negative, become positive. And now we can use the unit circle to figure out what is 3 pi over 4 is. So look at this, look at your unit circle. Can you tell me what is the sine 3 pi over 4? 3 pi over 4 is right here. And what is the sine?
Or 2 over 2.
So it's going to be the y value sine. So it's root 2 over 2. So, so this will give us root 2 over 2 from the unit circle. But what happens to your negative? You just have it. So this is your answer. Okay, so the negative, you just drop it. You guys all right here? What happens if I ask you for cosine negative 11 pi over 6? So cosine, if you refer to the notes, cosine in this case, do the negative disappear or the negative put it in the front? What do you think about cosine?
Disappear.
So it's an even function. So this is actually is the same thing as cosine 11 pi over 6. So the negative does disappear. Now look at your unit circle. What is cosine 11 pi over 6?
Square root 3 over 2.
So this one, right? 11 pi over 6, this one, and cosine is your x, so it's root 3 over 2. So this is root 3 over 2. So the cosine of negative 11 pi over 6 is still 3 over 2. So you do not need to worry about it. You guys understand what I'm trying to show you here with this last formula here, which is called the even odd. This is used for you want to change negative angles to become positive angles. This is used because of your unit circle here is all mostly positive. Otherwise, if it's a negative, you have to go clockwise, which is not wrong. You can do it, but if you know this formula, this function, you can actually either bring the negative out or the negative will disappear. Okay, you guys all right here with the even odd functions, all this? Yes, what I'm telling you here is this even odd functions is important, and then the one above it, the Pythagorean identity is important, and the quotient identity, reciprocal, and the cofunctions, all these are important. Now on top of it, it's not just important, you also need to know that these kind of formulas can switch around. What do you mean by switch around? For example, in this case, it's like, look at the first one, like sine theta equals to 1 over cosecant theta, right? So this is from the reciprocal identity. So it's like a formula. So you can multiply both sides by cosecant theta. So cosecant theta times with sine theta is still equals to 1. So you can also, this is also the same as the reciprocal identity that we just did. So what I want to point out here, class, is you can actually manipulate these identities, means you can add them, subtract them, multiply them, but make sure you do it on the other side too. And that is still going to be the same identity. For example, if you look at your Pythagorean identity, you got sine squared plus cosine squared equals to 1, right? This is a Pythagorean identity. You can actually move things around. So I can say that sine squared is 1 minus cosine squared. Or I can say cosine squared is 1 minus sine squared. So I can move like sine squared, I can move this cosine squared over there. So yes, these are all still good. So I want to point out to you that it's not always fixed like this with the identity here. You can always manipulate it. Okay. For example, 1 plus tangent square is equal to secant square. So I can move the 1 over. So guess what? Tangent square is secant square minus 1. And moreover, you can, for this, you can factor it. So can someone tell me what is a factor for a squared minus b squared? Anyone know how to factor this one? Anyone? A squared minus b squared? What's the factor? It's a minus b and a plus b. And guess what? You can factor secant squared minus 1. Your answer will be secant squared theta minus 1. And no square, just power 1. And secant theta plus 1. Yeah, this is all the same as this. Same thing with this. We can factor this as 1 minus cosine 1 plus cosine. Yep. So there's a lot of things we can do with this. So it's not just simply this identity that you see here. You can manipulate them, you can move them around, you can multiply them, you can factor them, as long as the value is the same. Now, please make sure you know that 1 minus c and 1 minus cosine, 1 plus cosine, you cannot change it to become cosine minus 1 and cosine plus 1. You cannot do this. These two are not the same. Okay, so 1 minus 2 is not the same thing as 2 minus 1. So that's why you cannot switch it around. However, I can switch this around by factor up the negative. So if I want to write 1 minus cosine and 1 plus cosine to become cosine minus 1 and cosine plus 1, I just need to put a negative on top, on the outside, because I just factor the negative 1 out here, and the cosine become positive, the 1 become negative. Plus I can do, because 1 plus 2 is the same thing as 2 plus 1. So that's 1 plus cosine is the same thing as cosine plus 1. So there are so many ways you can write this. Yes, sine squared can be 1 minus cosine squared, can be 1 minus cosine 1 plus cosine. And if I want it to be just flip around, I just put a negative in front, then your cosine will be flip around. All these special things, they are all the same thing. And where does it come from? It comes from the Pythagorean identity. So a lot of students struggle in this class is because you have to think outside the box. You have to like figure out this kind of identities can be manipulated, can be moved around, can be factored, can do a lot of stuff on it. So make sure you guys know what to do with it, especially when you guys do 7.2, the proving piece. Okay. Anyone, any questions for me? We'll do some word problems here. So next one we have is word problems. Question number 14. This is 6.2. Angle of elevation means it's an angle that you look up. Angle of depression means it's an angle that you look down. So we have a skier going down the mountain. So this fellow is going down this mountain with a vertical height of 1250. So this is called a vertical height, 1250. Okay. The distance from the top of the mountain to the base, this is the distance from the top of the mountain, this is called the base, is 2,500 feet. Find the angle of elevation from the base to the top. So this theta is called the angle of elevation because you're looking up from the base to the top mountain. So if you look at this, this is your opposite. This is your hypotenuse, because this is the 90 degrees here. Can someone tell me what formula? Sine, cosine, or theta that use opposite and hypotenuse? SOHCAHTOA, another meaning. So which one are we using for this question 14?
Sine.
So sine theta is equal to what?
1250 over 2500.
1250 over 2500. Can we reduce this fraction?
2.
Not 2, 1/2.
1/2, sorry.
So can someone tell me, using the unit circle, what is sine theta equals to 1/2? What is theta? What angle give us sine theta 1/2?
30.
So it's 30 because sine is your y, so it's 30 degrees or pi over 6. Now you cannot do 150 because your mountain cannot look the other way, so it has to be 30 degrees. So your answer in this case will be 30 degrees. You guys all right here? So what I want to point out here is majority of the word problems here are using SOHCAHTOA. They will give you word problems and you have to draw a picture, and your picture will be a right triangles. And they will provide, out of the 3 missing one, they will provide 2 of them. And then you have to figure out the angle here. by using sine or cosine or tangent because they give you 2. You do not need to find don't spend your time to find your adjacent because it's redundant. So a lot of students try to find adjacent using Pythagorean theorem. That's redundant because we do not need to find adjacent. We need to find the theta in this case. Okay. Does anyone have any questions? The word problems are very straightforward type. So make sure you guys read the questions really carefully. Okay. And then use SOHCAHTOA, obviously. Anyone have any questions for me here? Anyone have any homework questions for me? Because your 6.1, 6.2, and 6.3, this 3 homework is due tonight, actually. Anyone have any homework questions for me? Because we're going to start 6.4. 6.6 is not due Tuesday. I will move that a little bit back. I don't know why it's that. So we're going to do 6.4 a little bit today. Anyone have any questions for me? So 6.4 is where we graph sine and cosine graph. So this is very important. A lot of students struggle with this. So make sure you guys pay attention here. This is very, very, very important. So how do we draw the sine and cosine graph? Let's do the sine graph first. So we do y equals to sine theta. Okay. So so we're going to do the sine graph. So in this case, that this is your y value. This will be your theta value. So we don't use x. Usually it's sine x. So we don't use x, we use theta. To tell you that this theta is in angle, not, and so that means if you look at your unit circle here, your theta will be your this numbers, and your y value or y equals to is the answer for the value in this case. So what do we do here in this case? In order for us to draw it, is we use angles. So usually this is x and y. So I use theta here. So I will use this angle 0 degrees pi over 2, or not degrees. Let's do everything with it. 0 pi over 2 pi 3 pi over 2. This is super important. Please pay attention here. And 2 pi. So these are, if you look at your unit circles, these are your axis. Your x-axis at 0, y-axis at pi over 2, pi is back to x. So if you look at your unit circle here, can someone tell me what is sine 0 degrees? What is sine 0 degrees?
0.
0, because 0 degrees, sine is your y, so this is 0. So the first point we have is the coordinate 0, 0, which is right over here. Okay. And then we do the same thing. Now we do pi over 2. So pi over 2 is this fellow, the one that goes to 90 degrees. So what is sine pi over 2?
1.
It'll be 1. And then what happens when you go to sine pi? You get
0.
back 0. Let me put it down here. So, and then what happens when you go to sine 3 pi over 2?
-1.
It'll be -1, and then sine 2 pi is back to 0. So these are the 5 important points, and you need to know these points. You do not need to memorize it because it is in your unit circle, right? You just look at your y value for your for 0, 90, 180, 270, and 360 degrees, and you plot them. 0, 0 is here. Pi over 2, you will get 1. And then pi, you will get 0. And then 3 pi over 2, you will get -1, which is down here. And 2 pi, you will get 0. Now, this is what we call as one cycle for sine. So one cycle or one period is 2 pi. So the period for a sine is 2 pi. And if you draw the graph will be a hill and then a mountain, a value. So this is the sine graph. And yes, this will be the same throughout the whole graph. So that means it will be looks the same like here. So you keep on going. And this one, it will be a hill, a valley first, then a hill. So it goes a hill. So it goes something like that. So this, and you keep on going nonstop. So this graph is called the sine graph. Okay. So it will be from 0 to 1 to 0 to -1 to 0. This is how you get from here. Anyone have any questions with this sine graph? This is a basic sine graph. The period is 2 pi, means that if you look at the 2 pi here, this is your period. And it's like, you know, when you make cookies, you need that little mold. So this is like a mold, cookie mold. You just, you know, stamp it. And then this will go to 4 pi. This will go to -2 pi and so on. So that is your period. We need to know the domain and range for this. Can someone tell me what is the domain for this sine wave? What's the domain here? Since this keep on going, so the domain is what? All real numbers. The range, if you look at this, it goes from -1 to 1. It does have only one y-intercept, which is 0, 0. But for the x-intercept, you have a lot. You have 2 pi, -2 pi, -pi, 0 pi, 2 pi, 3 pi, 4 pi, and I continue 5 pi. So how do you write this? I'm not going to write -2 pi 0, -pi 0, -3 pi. That's a lot to write. So how do I write this in terms of integers? Is k pi 0, where k in this case is integers. So what I'm talking about here is your k can be 0, 1, 2, 3, 4, 5, -1, 2, 3, 5, and you will get all this. This is called the x-intercept using k pi here. And your this is going to be an odd functions. Why is odd function? Is because it is symmetry with respect to the origin. Okay, and when you have an odd functions, what happens to your angles? The negative, you bring it out. So that's why so we're tying everything together here. So these are all the graph for the sine. This is called a basic sine graph. And these 5 points are very, very important. Questions for me? I'm going to take attendance. Please do chat type present. Anyone have any questions for me with the sine wave? This is a basic sine wave. All right, so now we're going to talk about the cosine wave. So we will do cosine theta. And again, theta is your x, but I'm going to put this is your y. So we're going to use back the same angles, 0 degrees or 0 radian, pi over 2, pi, 3 pi over 2, and 2 pi. And don't forget, when you look at your unit circles, you're looking at the x values. So can someone tell me what is cosine 0?
1.
So the x value, this is 1. And what is cosine pi over 2?
0.
Be 0. So this is 1. This is 0. Cosine pi,
-1.
-1, and cosine 3 pi over 2,
Zero.
back to 0, and then cosine 2 pi is back to 1, right? So it's 1, 0, -1, 0, 1. It's a little bit different from your sine wave. So if I put this into your graph, so we got 0 here. The first one is 1. That's your first point, 0, 1. Pi over 2 will become 0. And then pi will become -1. And then 3 pi over 2 will become 0, sorry, 3 pi will be 0. And then 2 pi will become 1. So this, if you draw, is the whole valley. You'll be going down like this. Okay, and then once you reach up here, it will come back down. It also has a valley. And then this one is also a valley, so it go like this. And it keep on going. Okay. The period for this is still on the cycle is still 2 pi, because at 2 pi here, this is the basic cosine graph. And then from 0 to 2 pi, so this is your period here. So, and then after that, everything is going to be the same as him. Okay. The domain in this case is going to be all real numbers because it goes from negative to positive infinity. But your range in this case will be from -1 to 1, which is the same as your sine wave. Your x and y intercept is a little bit different because your y-intercept in this case is at 0, 1. And don't forget, the sine start at 0, 0. The cosine start at 0, 1. The x-intercept is also different. So if you remember the x-intercept for sine, it's going to be 0, pi, 2 pi, 3 pi, 4 pi. This is on the half. It'll be pi over 2, 3 pi over 2. Can someone tell me what will be the next x-intercept? If it's pi over 2, 3 pi over 2, what is the next one? Anyone? I guess. Pi, 3 pi over 2. What is the next one going to be? This is 1 pi, 3 pi. Anyone? 7 pi over 2. 9 pi over 2. 11 pi over 2. So a lot, and then this one will be -pi over 2, -3 pi over 2. So what you notice is that this number is an odd number, like 1/2, 3/2. Oh, sorry, forget about 5. Sorry, this is 5/2. This is 7/2. I'm jumping around. So it's 1, 3, 5, 7. It's odd numbers on the over 2, right? So how do you write that in your x-intercept? So please pay attention because a lot of students didn't know how to write this. So this is pi. How we write this is pi over 2 plus k pi. And k in this case is integer. So we still make all k as integers, and we don't want to make k as odd integers here because the other one is all integers. So we take pi over 2 plus k pi. So when k is 0, you will get pi over 2. When k is 1, you will get 3 pi over 2. When k is 2, you will get 5 pi over 2, and so on. And the same thing with negative. If k is -1, you get -pi over 2. K is -2, is -3 pi. So this is how you find it. Where is this pi over 2 come from? Pi over 2 comes from the first one that you see. Okay. And where is the k pi come from? Is the next one. So if you look at the next one, from pi over 2 to 3 pi over 2, the next one, you add pi to it. So that's why you're adding k pi, because the next one, if you look at this, you're going to add 2 pi. And then you're going to add 3 pi. And if you're going to go to the other side, you subtract pi, subtract 2 pi. So that's why you notice at this point, if you go left and right, we're adding and subtracting 1, 2, 3 pi's in this case. So that's why we add k pi here. So this is how you this is how we figure out the x-intercept. And this is going to be even function. Even function means that it is symmetrical with respect to the y-axis. So that if you look at this, if you look at the red line, if you fold this on this y-axis, this red line will coincide on the other side. And when I say even means that if you have a negative, the negative will disappear. So it will bring up. So this is the even identity that we talked about just now. So so this is why this is even, because you have it's symmetric with respect to the y-axis. So this is the cosine theta graph. Again, very important points, very important graph. Anyone have any questions for me here before we end our class today? So we just only touch base very basic stuff about the basic graph of sine and cosine. And then later on, we will begin to use transformation. Remember, we do up, down, left, right, vertical stretch, vertical shrink, horizontal stretch, horizontal shrink, reflection on XY axis. We will be applying this in this class again. However, there are also another way to do that without memorizing. Remember the transformation that I showed you last time in when you do exponents and logs and all those crazy things, you know, all the transformation. You can apply that into here. But there is also another way for us to do it without applying all those transformations. It's automatically, you know, you will get your answer. So the method I'm going to teach you guys here is I'm not going to use that transformation going up, down, left, right that you learned in when you do exponents and logs. And when you back in chapter 2, we will be using the new way to do it. But if you still want to use those transformations, be my guest, but I'm going to teach you another way to do it. And that way you do not need to worry about, you know, vertical stretch and horizontal shrink and all these reflections. It will be done for you automatically. You do not need to worry about all those different transformations you'll be performing. Okay, so I'll be teaching you that way because your book actually teach that way instead of going up, down, left, right, and all those, you know, the way that you learned before. So I'm going to stop sharing here. Does anyone have any